And so I think we're going to get started in about... Not going to be behind this podium very much though, because it's kind of impersonal and I like to walk around, especially because when I'm in a crowd of all these hundreds of people, I like to come out and chat. So first and foremost, I want to thank all you guys for being here. There's a lot of obvious great programs here, and I'm really glad that you guys took time out of your schedule to spend it here. So what I want to do in this session is do my best Mythbusters impression. So as long as anyone who's familiar with that, it's a TV show. I think it's over now, but they take common myths and they try to bust them. And as anyone knows, these days artificial intelligence is being talked about maybe too much, and I wanted to myth bust some of the beliefs when it comes to artificial intelligence and beyond. So I'm also at the end going to give everyone a quick preview of something that we built recently, so that'll be fun as well. But here are the myths that I'm going to be concentrating on. Chiefly one, AI is a new field. Number two is that artificial intelligence it means robots. I wish it did. I'll give you a preemptively, it doesn't. Artificial intelligence is here to replace humans. And number four, the singularity is imminent. And for those who don't know, the singularity is kind of like Hal from the popular movie Space Odyssey. It's the idea that that projector is going to essentially become sentient and maybe turn against us somehow. And I guess there's a small chance that that may happen, so I won't badmouth the projector too much. But I'm not going to be, I'm not advocating that that's the case right now, I'll tell you that much. Okay, so number one, the idea that artificial intelligence is a new field. It's not. Artificial intelligence, you guys don't have to read this because it's very small text and not very painful. But what this is a paper from 1943. And it came out in association mainly from the Department of Neuroscience at the University of Chicago. And what they thought was, hey, the way that our brain works, wouldn't it be neat if we could make a computer work that way? And so I think that is obviously a really neat thing to explore. And that concept started getting picked up by a lot of really famous, interesting people. So the lighting in here is an optimum as well, and that's to make things kind of really kind of into this. But over here is a picture of three individuals. The one standing up is from the movie about his life. It's the Alan Turing, the imitation game. And so, as you guys know, or may not know, during World War II, a bunch of code breakers got together, and the way that they deciphered German messages is by using really cutting-edge advanced computing at that time. And when they started to see, hey, wow, this computer system is capable of doing something we had never thought before possible. What's going to happen to this stuff? Where does this end? And how can this continue to occur? And so they started saying, you know, this idea of artificial intelligence started being talked about. Now, can all you guys hear me, or do you want me up against the podium? You guys are good? Okay, good. So, but why now? Because it's not, okay, so Andrew, it's not a new field. Then why are we talking about it right now? Because then why hasn't this stuff happened before? So what happened now and why people are talking about it is for three main reasons. So number one, and this is the most important, that's why I talk about it first, is right now computers are capable with the compute power available to do things that all those pioneers had previously not been able to do. So what does that mean? Those computers that they were kind of operating, and if you've seen that movie, it's kind of really kind of elementary, just didn't have the level of computational power needed to work through the algorithms and data to build these artificial intelligence systems. So a fun example of, and this is kind of like obvious, this device right here, a smartphone, everyone has one. If you don't, I guess it's called a dumb phone, has a lot more power in it than what we landed on the moon with, right? And so if you think about it, and that occurred after a lot of these pioneers, that compute power has lent itself to folks being able to play around with things and do things never before possible. So the second one is digital data. I put data, but it's digital. Now think about this. Those early folks writing those papers, etc., they needed digital data to feed into these computer systems. There wasn't an internet around, and so the amount of digital data necessary to actually build these tools wasn't there. So what happens next? Well, it's the algorithms. Algorithms have always been around. And algorithms is a fancy word for getting a line of it's kind of like math, but it's like if the chair is green and no one's sitting in it, someone can sit in it. If the chair is red, and you can go through it and build really complex ones, obviously. But if you didn't have the compute power and you didn't have the digital data to train with, you couldn't make many breakthroughs when it came to your algorithms because they all were hypothetical. And so when you break it down like this, it actually becomes almost not very extraordinary, but what's going on is extremely extraordinary. So that myth, I think we could all put to rest. The idea that artificial intelligence is a new field, it's not. But I think in many ways, it's kind of like what we're seeing with electric cars or self-driving cars. There's been cars since the Model T, but what you can do with them has continued to change and evolve. And so what you can start to do with software and interact with it has changed as well. Let me give you a quick anecdote about what you can do with this stuff. Everyone here probably has interacted with Amazon or has heard about it. They kind of buy everything. One, they recently bought Whole Foods, the grocery store. Now, a lot of people think, well, that's great because now they have physical stores to sell from. Yes, but they also purchased all the data in that transaction of everyone's purchases at Whole Foods to date. Exactly. So when you start thinking about the data, feeding all this computational power, you guys are going to be walking around starting to realize, hey, I know why they're doing that. I know why they're doing that. Think about this. Amazon, before they ship something to you, sometimes, let's say that you really like looking at specific types of whatever. And they know that usually after you've looked at an item 4 times, you press purchase. That's just, it happens more often than not. So what they'll do is when he hits the second time looking at that object, they're gonna send it to a warehouse near him already. He hasn't purchased it yet. So then he buys it and you're like, wow, this showed up the next day, that's incredible. So all this stuff with artificial intelligence is happening, and it's not necessarily a breakthrough in that you couldn't get thousands of people sitting around to do this, but that's very cost inefficient, and when you can get computers to do this instantaneously, it's amazing. Last little example I'll give you guys. If you're not from New York and you were traveling, you purchased something, you might have purchased something and not told your bank company that you were gonna be in New York City. All of a sudden you get that phone call. It's not like we all have people looking at all our banking interactions. What happens is an artificial intelligence system sees something irregular, bumps it up to a human, and they can see that. And that's only possible if you have the compute power, the right data, and the right algorithms. All right, the next one is that the idea that artificial intelligence is robots. When I got involved in this field, I also thought to myself, this is a picture of the Terminator, but because it's on a computer, they don't want you to see it, right? I got involved in this field, and I also thought that that might be the case, that I was gonna see a robot. Now, the idea of a robot is completely separate from artificial intelligence. A lot of the time, though, these tools might be called a robot. So the idea that Amazon has a robot that ships you things when you look at objects, it's not a robot, it's software. But I think just based off of the way we've always thought about these systems, we think of them as kind of taking a human form or taking on a more physical form. So I'm from a company called Ross Intelligence, and early on, we built tools in the legal space that streamlines research and pulling information. And then when we came out, people were like, this robot lawyer is gonna take our jobs, et cetera. And so it's not a robot. What artificial intelligence is, as you guys, I think, have started to see, as well as you guys already knew, it's just software. Now you can add that software into a physical robot. As a matter of fact, you can do really fun stuff like get that robot to learn how to do certain movements and use the same software, but they're 2 different fields. And when you talk about artificial intelligence, it's actually broken down into 4 main areas. So the first one is learning, and that's machine learning. So what does that look like in practice? All right, I take a photo of this crowd and say we're all friends. I'm actually gonna tag each one of you on Facebook. But these days, if we had all already been friends, it's actually gonna tell me, hey, do you mean to tag this person and that person? How did that happen? It's not magic. What they did was this. Every time you had tagged a friend and you had tagged a friend, they trained that into a system. When it saw enough examples of your face, it's now suggesting that to you. It could be right, it could be wrong. But when it's right and you say yes, it learns and it takes that into effect and it gets smarter every day. That's the machine learning. The speech is Amazon Alexa or Siri. It's not that it understands us. It's that it can take this vocal and translate it into words, which sounds pretty elementary for us, but it's actually a huge breakthrough even just 5-10 years ago. The next one is computer vision. That's kind of like what I said with the Facebook example with the photos. Here's a fun thing. I mean, this has a lot of application even in law. If you can start training systems to identify even something as simple as what a parking ticket looks like and extracting the information from that and then suggesting different routes and different things you can do with it, you can streamline a lot of what some folks do. The last one is language. Now this one's super important. Typically you've also heard this being called natural language processing, and this is what happens here. They take some of the similar things that they use to identify images, different examples and different things in context, but then they do that with words. So that when you, instead of having to put information in rows and columns, you could actually ask a piece of text a question and get an answer from it. Now, that sounds kind of far-fetched. Let's give an example. I want to know what year Abraham Lincoln was born, and it's in a book. I can shout at the book and say, hey, tell me what year it is. It's not going to answer me. But if I had a system built with natural language processing in it, and I typed that question in, it's going to be able to essentially mimic the process of reading and then pull up something that might say, Abe was born on this day, or the president was born on this day, because it knows your question is related to that person in context with what it's searching within. So it's a complete game changer when it comes to what search looks like. It's not looking at keywords, it's looking at context. I got a lot of good nods, which is good, because there's going to be a huge test after this one. So I think the idea that AI is robots has been debunked, and you guys now know it's software. You guys are all AI experts right now. You're AI certified, and we're only halfway through. So the next one is artificial intelligence here to replace humans? Well, I think similar to what we always do with the robot and that conversation, people get threatened a lot by this technology, and for rightfully so. This is a picture of Garry Kasparov, who was a grandmaster chess player who Deep Blue, the computer system by IBM, ended up beating. Now, he doesn't look so happy in this picture. You can see he has his hands in his face. And actually, very famously, I think a year or two before he lost, the IBM team asked, hey, you know, you played it, and he handily defeated the system. They said, is there any tips that you can give us to make it better? And he said, yeah, next time can you program it not to lose so quick? Not good. So eventually he loses to the system, and now at that time that was a huge breakthrough. But why that was a breakthrough, everyone, wasn't necessarily that it understood how to play chess. It didn't. You know what that computer system did? They latched onto that first wave of what's possible now, a whole bunch of computing power. They showed it in books and in examples, every optimum move for every position on a chessboard. Sounds like a lot of work, but they had a lot of time to do. And then once it had that in it, it just kind of responded and did the math. It's like a giant calculator. So that was a huge breakthrough, but it wasn't what we're seeing today. And I don't want you to get confused with that. And I'm going to return to the theme about defeating humans in a second. What you're seeing now with the artificial intelligence is completely different. Now, this is a game called Go. And the game of Go is a much more difficult challenge than what you saw with chess. Now, why is that? On a Go board, not chessboard, Go board, there are enough moves at any given time as there are as many atoms in the universe. So you can't do the Deep Blue thing. You can't go in and program every possible move. We don't have computational power at that level. So what did they do? They started using machine learning, showing it different examples. And then the machine system started suggesting different moves. And it started playing against humans, getting better, learning, getting better. Now, the game of Go was told that was impossible to teach a computer system. But recently, the greatest grandmaster, who's pictured here, also hands on the head, lost to the Go system. Now, what's really neat about this game, though, was that there was a series of matches. I believe the Alpha Go system won 4-1. It's usually games of 5, I believe. But what happened was, I think in game 3 or 2, the Go system played a move. And this grandmaster started kind of getting really confused. The people on TV, the commentators, were like, that's a huge mistake. No one makes that move. That's not even what is that? But what had happened was this system, because it wasn't constrained by precedent, it wasn't constrained by any of the past games that had been played a new move based off of what it thought could be a good one in that situation. It was called Move 37, and it won the game. Now follow this theme, because I'm going to bring it all together now about replacing humans. What happened to Garry Kasparov? Well, what happened to Garry Kasparov is right now he's the biggest supporter of artificial intelligence in the world. Why? Because he said, look, that changed the game of chess. It actually led to this new way of playing chess, and it's called centaur chess. And what that is, it sounds funny. It doesn't involve half humans, half horses. What it involves is half like a robo person, software of course, where a chess playing computer system is on the same team as a grandmaster. They play together. And when they play together, they don't lose to a single human player or a single computer system. Now, what happened with Go? Remember how I said the human did end up winning a game there? Well, what happened? The grandmaster went away, started talking to his friends, other grandmasters, and said, what about that that move 37? Never thought of that. That's incredible. It played the system again and made a similar type of tactician move, similar to that line of thinking, and it beat the system. So what happened there? That system ended up advancing the game of Go by maybe 10 years, 15 years, who knows, until that had started being played in junior tournament play, seeing the results of that and coming and weaving all the way up. Now, I'm obviously using that example on purpose in a legal area. We rely on those precedents, and that's why these systems are going to start to be able to suggest different points of action, different points of information when you're doing research that you might not have thought about, which would help you do better. And so it's actually a symbiotic relationship. These are those famous, really cute fish, the ones from Finding Nemo. And they have a symbiotic relationship with the coral. And that's kind of what we have to start thinking about with these systems. They're not here to replace, they're here to enhance. And they're here actually as a profession, we're gonna be able to elevate our game. This is the last one, the idea that the singularity is near. And as I mentioned, the idea of the singularity is that these computer systems are going to become sentient and actually start to turn against us and get smart. Now, this obviously is a theme that we've also seen along the robot side for many, many years. The idea that there are going to be a rise up of machines. In this case, this is an old Nickelodeon poster, Toba the Great, man-made monster with every human emotion coming to snatch people up and take your job too. This is a picture of a plane. And why I bring that up is, yes, these systems can mimic the way that human beings seemingly think, but they do not think in the same way. After these systems won, when that AlphaGo system won at Go, the tournament was played in Seoul, South Korea. It didn't go out on the town, have a couple shots of soju, have a beer, and really celebrate what it was up to. It's because it doesn't exist. And why I bring that up is that this idea that there's going to be this rise up in this kind of conscious building of these AIs, I think does a lot to turn back a lot of the progress that is being made. Now, why is there a picture of a plane? I was at a conference once and someone said, and I like the example, you know, planes are modeled to fly, birds also fly, but we don't worry about these big planes nesting in our backyard and feeding little baby Cessnas and kind of hanging out. And it's kind of a ridiculous example, but I thought it would be fun to include it here as well. The way that we see things, and I think the same will go for a lot of the new legal technology companies, is that there should be a seamless interaction with your technology. The idea that you're pressing on filters, the idea that the onus is on you to go through a whole bunch of information, well, that's just the old way of doing things. With systems like the one that we've built at Ross, you just ask your questions, you get answers to that, and you can actually just get to work and be a better lawyer overall. So I have about 2 minutes, but I think we did a good job. We went through, we myth busted a lot of those myths. AI is not a new field, but what's happening now is new based on the factors that I went over. Artificial intelligence isn't robots, although it can be placed in robotics. Artificial intelligence is here to replace humans. As a matter of fact, we saw in many ways that it was actually here to enhance. And the last one, the concept of the singularity is inevitable. The idea that these machines are going to rise up against us is simply a foregone conclusion, not true. So we stamped that myth busted. Now, for everyone here, if you guys actually want to see what this stuff looks like in practice, you can sign up and actually use one of our AI systems completely for free. It's called EVA. If you go to eva.rossintelligence.com, what it does is you grab a brief of law, you drag it in 1 second, it'll show you all the negatively treated cases within your brief. You can open up a case, find similar language used from a case you like as to any other case. If you're in a case and you want to find out if it's answering your legal research question, this one's fun. You simply ask your question and it'll summarize your case in a way that answers your research question. If you ask it a different question of that case, it's obviously going to come up with a different answer. So think of it as if you have a team of folks who are just waiting to help you in your practice, and you should give it a try. It's completely for free. It's really new and really fun, so I'm happy that I was able to chat about that as well. So like I said, thank you all for coming. Enjoy the rest of Legal Tech, enjoy the rest of the folks on this stage, and have a great evening.